This lesson, we're going to be talking about some properties of definite integrals. And remember that when we are talking about an integral, we're always going from a lower bound to an upper bound. So basically, we're talking about the a value should be smaller and the b value should be bigger. All right, so that's kind of how that look always is. So some properties that we have is if your a value goes from an a to an a, that means there's no width because you're talking about areas of rectangles in theory. And so there's no width to it, so your area is just going to be a 0. If you find that the values seem to be backwards, where you have the bigger value on the top or on the bottom and then the smaller values on the top, then you want to fix it and adjust it just by switching them around. But when you do that, you have to negate your area, right? Because you're actually going backwards. And so you're going to have a negative to that. Okay, so you'll switch your sign. If you have individual pieces, so like an x squared plus x, you can break them up into individual pieces. So you can find the area under the curve of the x squared plus the area under the curve of the linear, add or subtract those sums together. If you have some sort of a value, and this happens pretty frequently, some sort of a value multiplied into a function like a 2x squared, you can actually take the 2 out, find the area of the x squared, and then go ahead and multiply it back by the c. All right, that's going to save you some, it's going to make the math a little easier on certain situations. So that one's going to be pretty common. And then this one is, it's basically the sum of the parts equaling the whole. So if you go from an A to a P and then a P to a B and find the areas of those individual pieces, that also represents the area from A to B. All right, so we're going to do a couple examples and they're going to be very visual. We don't quite have the fundamental theorem of calculus quite under our belt yet. And so that means we're still finding the area under the curve. That's the main idea, which also means that since we don't have the math yet, everything is going to make some sort of a shape that we can figure out. So before I even begin, I might as well take a look at these areas and just go ahead and find the areas of them. So then I kind of have all my values ready to go, and then I can just be adding, subtracting, doing whatever I need to do. So first one is I have a triangle, and that triangle is a 3 by 6 triangle. And so half base times height. So 18 divided by 2 is going to give us an area of 9. Here we have a circle. Here's our center of our circle. It goes up 4, out 4. So we're looking at a circle with a radius of 4. And so our area on that is going to be 16 pi r squared. But we have a semicircle. We don't have the whole thing. So the whole thing would have been 16 pi, but we're cutting it in half. And so that half of this whole thing is going to be 8 pi, right? And so if we need to cut it again, we'll see what we need to do. But the area of the semicircle is 8 pi. And then this triangle is 1, 2, 3, 4, 4 by 2. And so we're going to multiply that, divide by 2. So that's going to give us an area of 4, but it is below. So I do want to consider it as a negative slope. All right, so I got my areas, and let's go ahead and figure out what areas they want us to find. So from -8 to -5, we're finding the area under that curve, which is just 9. So that one's done. And if we're going from a -1 to 7, we're going from here to here. So we're going to go ahead and take this semicircle and break that 8 pi into 2 sections, each one being 4 pi. So we want that area right there. So that's going to be 4 pi minus, because it's a negative area, minus 4. So that would be the area under from -1 to 7. 7 to 3 is backwards. And so I want small to big. So if I want to figure that out, I would like to go 3 to 7, not 7 to 3. But if I do that, that's when I have to negate the area. I had to switch the sign. And so this, I just need to figure this out. So if I'm going from 3 to 7, that area is -4. However, because I was technically going from 7 to 3, so I was going backwards, so we were undoing a -4. So that actually turns our area into a +4. All right. And then we're going to go from -8 to 7, so the whole thing, which means we have 9 plus the 8 pi minus the 4. And we'll simplify as much as we can, so we can put the 9 and the -4 together, and so that's going to get us a 5. So 5 plus 8 pi is going to be the area under the whole thing. And the last one is if we go from -1 to -1, we wouldn't have any area at all. And so that answer is going to be 0. All right, so that was a couple different properties, breaking some things up, manipulating it, and trying to find out where all our areas under the curves are.